Hello, welcome to this lesson where we are looking at tangents to circles. Okay, this is our fourth lesson in this topic, and we are building on what we already did. So after this lesson, we're going to look at how questions do come in the exam, a combination of all the theorems. So now, here we want to look at the three theorems that are associated with the tangents. Okay. That is basically what we want to provide. So remember that this channel is meant for people that are writing their grade 12 exam as well as grade 9. So grade 12 exam could be for GCE or the internals, okay? Even grade 9, there are externals and the internals. So everyone is scattered for here. So make sure that you subscribe to this channel and you follow through all the lessons. The lessons are properly labeled, the topic, the grade, the lesson, everything. Okay? So let's look at what is involved here. What is a tangent? A tangent to a circle is a line which meets the circle in one point only. Okay? It's a line that, in some books they say it's a line that touches the circle at one point. It's a line that touches the circle at one point. So that is what a tangent is. That is what a tangent is. So if you have a case such as this one, this line does not touch the circle, so it's not a tangent. This is not a tangent because it cuts through the circle, touches the circle in 2 points. So the tangent is a line that touches the point, that touches the circle at 1 point, like this. That's a tangent. So we need to understand that. So that is a tangent. That is a tangent, is a line that touches or meets the circle in 1 point only. That is very important for us to know. Okay? So when it comes to these theorems, or the first one, what is it saying? A tangent is perpendicular. A tangent is what? It's perpendicular to, a tangent is perpendicular to the radius. These three words are their point of contact. Okay? Perpendicular meaning at their point of contact they form 90 degrees. Okay? Then we have a radius and a tangent. So you know that at the point that they contact, I mean they contact, yes, they will form a 90 degrees. That is what we mean by perpendicular. So this is what I have shown here. Okay? These are theorems that are coming from one of these books. This is the way the notes are presented here. So if you have got these books, this is where these notes are coming from. So, what we are saying here is, even this side, it is still at 90 degrees. So, make sure, get to understand this one. This is not going to be indicated in the exam. No. They will just show you that here you have a tangent, okay? And then there's the radius. So after you've just a tangent and the radius, you should be able to know that this point where these two meet, they form what? A 90 degrees. That is what the first theorem does state. A tangent is perpendicular to the radius at the point of contact. Okay? At the point of contact. That is why you have seen even here. There's a tangent, then there's a radius. So here we are at the point of contact, they form what? 90 degrees. Even this side at the point of contact, they form what? 90 degrees. We are borrowing from the first theorem that we did mention. So I hope you've gotten the concept there. So we can proceed to the second point. We can proceed to the second point to look at what they are talking about. What are we saying? We can proceed to the second point. Okay, we can proceed to the second point to look at what they are talking about. So, what is the second point saying? The tangents to a circle, meaning here we are talking about more than one. The tangents to the circle from an external point are equal in length. The tangents to the circle from an external point are equal to the length. Now, please, I want you to follow me here, okay? So what these people are talking about and what you are supposed to write, for those of you that write the notes from these presentations, is here, this distance is equal to this one. So we can write that AT, meaning the distance from A to T, is equal from the distance to the distance from B to T. That is one point that we are supposed to write there. Then the second point, as you have seen, these two angles here, this angle and this one, they are equal. So we are going to say angle ATO is equal to angle BTO. Take note of that also. Thirdly, I want you to take note of these angles also here. This angle and this one, they are equal. So we can also say angle AOT is equal to angle BOT. I hope you are following these things the way they are presented. Don't get to confuse them in the exam. As you can see here, what are we dealing with? We are dealing with radii. We've got this radius and this one. Okay? So, in an event where, I hope you've gotten these 3 points, you need them as we are going to be dealing with the questions that combine all the theorems. Take note also that here we've got a concept. I mean, we have got 90 degrees, even this one we've got 90 degrees, which is a build-up from what I presented in the first theorem. So, if I can use this same, diagram to say, so let's say we have a straight line here, which you are going to find in other questions. Okay? What are we seeing here? What we are seeing is that we have this line as well as this one. Then now we have this point and this point, which is these two. Then we have a straight line here. Okay? We have a straight line. So what are we getting? This is an isosceles triangle. This is an isosceles triangle. That tells us that the base angles are equal. So meaning this angle is equal to this one. Because you're going to have a case where this angle is given and now they're asking you what is angle TAB. Angle TAB. They're asking you for this angle here. We know that the whole angle is what? 90 degrees. We know that the whole angle is what? 90 degrees. So you need to understand that. Okay? So, also what you're supposed to know is that this angle here is equal to this one. But this is not 90 degrees because 90 degree constitutes this, the contact of the radius and the tangent. And this one is not the radius. So take note of that. Take note of that. Okay? Take note of that. I think this is what we are supposed to understand here. Because there are cases that you are going to find in the exam where you have something like this. I hope you're getting my... I've got something like this. Then you've got a... if this is... Sorry. If this is the center here, this is the center, then they give you that this angle is what? 60 degrees. Just an example. Then find this size. Okay? Find this angle here. Find this, make this 50. Find this angle here. So you need to understand that if this is an isosceles triangle, it means this angle is equal to this one. So after you have found the size of this angle, you'll have now to know that, okay, the whole angle is 90 degrees. So you're going to subtract this one from 90 degrees to know what is remaining here. Okay? So that is that about this second part. So let's look at the third and last theorem. Okay? The third and the last theorem. Please, I hope you've written down these notes. Okay? By the end of your study with us, you should have filled up about three maybe exercise books, those 192 pages or bigger, because there's a lot of work that you need to write down. Okay, so we are looking at the last one. The angle between a tangent. The angle between a tangent. The angle between a tangent. We have a circle here. The angle between a tangent. The angle between a tangent. Sorry. Say this is a tangent here. Okay. The angle between a tangent to a circle and a chord through the point of contact. This is the tangent and this is the chord. So they're saying the angle between a tangent to the circle, which is this one, and a chord, this angle here, this is the angle that we are talking about, through the point of contact is equal to the angle, in the alternate segment. Very good. So this chord has divided the circle into two segments. So one segment is this one, which is closer to the tangent. Okay, this segment here. We have, this circle has been divided into two segments. There is this segment and this other one here. Now, the alternate segment that is being referred to here is this one. The angle is here, the alternate, this. So any angle that is going to be formed in the alternate segment is equal to this one. And what are we talking about? That angle, if I can call these two arms, this, we have one starting from here and this one. Where we are going, these two, anywhere where they're going to meet here, the angle that they will form is equal to this one. What am I talking about? If we have this case and this one, this angle is equal to this one. Similarly, if I brought it here, also the same thing, this angle is equal to this one. Even if it came here, this angle is equal to this one. Alternate segment, alternate. If you go through these things, like looking at where we are coming from, you understand like already here we are looking at also angles like in the same segment. If you look at these, a lot of that other theorem also does apply here. So that is what we are talking about. Now in this case, what are we saying? This angle that is marked in blue is equal to that angle. It's in the alternate segment where we have, this is a tangent and the chord is this one. If we have, say we have A, we have B, and maybe C. We have A, B, C, D, E here. So we are saying this angle here, which is ABD, is equal to ACB. It's the alternate angle. This one. This is our chord. That angle which is formed in the alternate segment is equal to this one. If we are looking at this one, the chord that we are using is this one. The angle that is formed in the alternate segment is this one. Please get to understand these theorems. We'll need them as we look at questions. Otherwise, this can even be made to be the end of the topic, but I just want a situation where we're going to look at good questions from the past exam papers to see how all the theorems are integrated in one question. All right. So, having said that, let us now look at the examples under these theorems. Okay. Hello, so here are the examples that we are supposed to look at. Okay, here are the examples that we are supposed to look at. I hope the best that you can do is you pause the video, try them out based on the explanation that I gave, then you compare with what I'm going to do. That will be better for you. In case you make any mistake, it's better to learn from your mistakes. Okay, that will be better. So let's go through them. Let's go through them together. Okay, they're clear. So we start with the first one. remember, what are we using here? We are using those rules or those theorems. Well, 3 of them. If there is any other which is appropriate, either that has to do with the angles in a triangle, any other, we are going to apply them as they come. Okay? So, the first thing here that we are supposed to do, we want to find the value of what? Here we want to find the value of x and y. Find the angles marked with a letter. Okay? So the first one, we are here. So I'm not going to waste time. When you look at x, like I said that you're supposed to pause the video, then you work them out. 50 is equal to x. Okay? The issue of the angle in the alternate segment. We have a tangent here. This is a tangent. Then the chord is this one. So you've seen this angle that is formed here and the angle that is formed in the alternate segment. So this is 50. If you want, you can write angles in the alternate segment. Okay? The angle in the alternate segment. It's as simple as that. What about y? Y, the method that we can do, we can use 2 methods. One of them is where we find this angle, because we know that y is equal to this angle that we do not know. So if you add these 2 angles and subtract them from 180 to give you this one, then you will just conclude that this angle is equal to this one, because they are angles in the alternate segment. That is one method. Then the other method is the method where you are going to add these 3 angles, because you know that angles on a straight line add up to, so here we have y, then here we have what? 62, and this side we have x. What is our x? X, we said it's what? 50. So we need to add now these angles and get what? 50. 50 plus 50, I've gotten a 50 from here. We're going to get 100. Then we have 12. So we're going to get 112. Okay? So this is going to give us 112. I'm going to say 50 plus 62 plus y is equals, supposed to get 180. Then this is going to give us what? 112 plus y is equals to what? 180. Then we say y is equals to 180 minus 112. What do we get here? This is 10, we get 8. We have 7, 6. Okay? What are we getting? We're getting 68. So we can conclude here also to say y is equals to 68. Y is equals to 68. Are we together? Y is equals to 68. So we have dealt with both of these angles in the alternate segment. Please, 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 please. Let's go through these concepts until we understand them. Okay? The exam is always easy. What is difficult is a strategy. If you haven't applied the correct strategy, you are going to think the exam is what? It's difficult. The exam has always and will always be easy. As long as your strategy is difficult to pass the exam will always remain very, very difficult for you. When it's in the actual sense, it is easier because other people are passing. How come it is you who is remaining? So it means the strategy that you use to write the exams is not workable, so you need to change. Otherwise, the exam has always been the same. Any examiner does not target to fail the learners. Okay? So it's a question of how you prepare. All right, so we proceed. We proceed. Find the angle marked with a letter. Okay, so we are here now. We are here. And I want you to remember what we were talking about. So this is the guide. This one is the guide. Okay? And you should remember what we said. Let me take you back to what we said. Here we have a triangle. We have a circle. Remember? Then we said you have got what? Two tangents. Two tangents. The distance from this point and this point is equal. That is what we are having here. Here we have a tangent. This is a tangent. So meaning the distance from this point, okay? The distance from this point, if we can say this is our A, our C, and our D. So what are we saying here? The distance AB is equal to the distance BC. Okay? So we have an isosceles triangle. We have an isosceles triangle. That is why we did those rules. So we need now to know that, I hope you are following me. We need now to know that if that is the case, it appears we have something like this. Then here we have what? 54. This is a grade 8 or 9 question. When children see this question, they know that, okay, this angle and this one are equal. And angles in a triangle add up to 180. So we need now to subtract first this angle from 180. Then what we are going to get with, because the angles that we have are equal, we'll divide by 2. So we say 180. 180 minus 54. What do we get? We get 6 here. Then here we have 7. What are we getting? 2, 1. This is the angle that is supposed to be shared between these two that are equal. So here we divide by what? By 2. Into 12 we have what? 6, 3. Okay? Here it's 6, there 3. There. So this one is what? 3. So we can conclude here that this K is equals to 63 degrees. Okay? K is equals to 63 degrees. I hope you are following me. I hope you are following me and you are writing these things down. Then, if K is equals to 63, we are saying now this K is alternate to this angle. So even this angle is what? It's 63. I hope you are following me. What do we have? We have a triangle now. This triangle that is given inside, it's given, these two are given as per the question, as per question. So we have this and that. Then we found that this angle is equal to this one, which is 63. So this is also still telling us that this angle here is what? It is also still 63. So it appears even this one here, okay? Even this angle will remain what? 50. This angle is going to remain what? 54. Okay. These two, after we got them, okay? If you get this one here now, this is taking us exactly back to what we got. This is going to be 63. So when you add 63 plus 63, you have to subtract from what? You are going to get 54. The other method is that if this is 63 here, this is also 63, then this is what? 54. So meaning this angle is an alternate to this one. So we can also conclude that this one is what? 54 here. This is, so M is equals to 54. M is equals to 54. Okay? M is equals to 54. Let's move on. Let's move on. Look at the last example. Okay, so here, you have to understand something. It is very important that you understand something. Okay? It's very important that you understand something here on this question. We have the tangent, we have the tangent and the radius. We have the tangent and the radius. So what does that mean? We are given that the whole angle here, that is what we are given. The whole angle here, this is supposed to be 90 degrees. Take note of that. Okay? But then, even before we proceed to look at what we need to apply a lot of concepts here. So if the whole angle is 90 degrees, so we need to subtract this one from 90 degrees. What are we going to get? What are we going to get? Hello? What are we going to get? We're going to get 46. 90 minus 44. What do we get? 6, 4. So this 46, it will mean that this part here is 46. Alright? I hope you are following me. It will mean that that part there, it's what? It's 46. Now, if you can remember the first concept that we looked at, or even just what I'm explaining here, it has not just been mentioned. This is the center of the circle. This is the case. If we say this angle here is 46, this is the radius, which is the same distance as this one. So even this part is supposed to be 46. So what does that tell us? It is telling us that even this angle here, where there is P is equals to 46. Are we together? Based on this concept that I'm explaining. So you've seen how that the point of contact where they form 90 degrees helped us. It helps us to find this angle here. Okay? It helped us to find this angle here. Then we subtract, we find P is equals to 46 also. Now we are remaining with N. We are remaining with N. Okay? We are remaining with the N there. So this is the question that we have. Okay? So this angle, before I bring in what is inside, this is 44 here. Which one is the alternate angle to this one? This is also 44. Take note of that. So this angle here is 44 degrees, using this one here. Okay? Now, take note here, what are we having? We have 28. And then down here we found what? 46. I hope you are following me. Then this side, what did we get? 46. Then we have N. Okay. So now, I want to get this triangle that is inside. I get the whole triangle that is inside here. I hope you are following me. Okay? I hope you are following me. Or I can use this same part here. Let me, after I have done that, I can get rid of this. We remain with, this is our triangle. So we say, what is the size of this one here? What is the size of this angle? The size of this angle now, it is 46 plus N. Remember, there's an N here. Then these two here, you also add this. 28 plus 46. What are you getting? Or what are we getting? Okay? Let's add. What are we getting? We're going to get 14. This is what we're going to get. So meaning, this angle here, we can reduce, or we can reduce to 74. Okay? When we add those two together. This one gives us what? 14. We bring one the other side. When we add this 6 and 7. So now, these three angles, they should give us what? These three angles must give us 180. So what are we supposed to do to get N? What are we supposed to do to get N? We are going to say 44 degrees plus 74 degrees plus 46 degrees plus N, we must get 180. So we add these ones. 74, we add it to what? 74, remember that this and this one will give us what? 90. Okay. So we are going to have 90. 44 plus this one, they give us 90. Then we have 74. What are we getting? We are getting 4, this one, 1, 6. Okay? So, if we are to proceed with our equation, we are going to get 164 plus n is equals to 180. Then we say now n is equals to 180 minus 164 degrees. So 180 here. What do we get? 6. Okay? 6 here we have 7. What are we getting? 1. So n is 16. Our n is 16 degrees. So this is how we use these theorems to find the degrees that the questions require us to do. So now, as per our tradition, I'm going to give you questions that you are going to use, that you are going to solve. I give as many as possible, but you can solve a few. Those of you that do submit, even 2 are enough, you can submit. The rest, they are there for your practice. Some of you do not have textbooks, so I give you as many as possible. That's the idea, just. So, in the next lesson, in the next 2 lessons, we are going to now look at questions in form of revisions from different past papers and textbooks, where we are going now to apply all the 8 theorems. So before you come to these 2 exercises or 2 presentations that I'm going to make after this one, you make sure that you have gone through all the lessons and you have appreciated the concepts from lesson 2, especially from lesson 2 up to this, which is lesson 5. Then you can come to the last 2, because we'll just be revising. There's nothing new there. We'll be revising, so we'll be applying these rules. So let's get to the exercise. Let's get to the exercise. So here we are finding these angles marked with letters. Okay? These angles marked with letters. These angles marked with letters, here we have got 6. Got 7. 7 is what we did together. You can do this one. Question 8. 11 here. Question 13 here. Okay. Question 13 here. We have another interesting question here. Question 14. This is a very good question. This question here, find y and x. Okay. Even this question here, you can do it, except that you have also to appreciate the diameter thing here. Okay, so you need to go and look at the previous lessons. Okay. Okay, this question here. Find RPSQ. Question 6 here. Question 6 here. Okay. This question here. Question 16. Okay. Look at question 13 here also. Work it out. Please, if you have any of these books, you can use them. That is where these questions are coming from. They're very nice books. Okay. That's where these questions are coming from. But at least I've compiled everything that you may need. But in case you have any of them, these are the books that I've used. Thank you so much. Wait for other lessons to come. Make sure you subscribe to this channel. Goodbye. Good luck.